Hello, in today's lesson we're going to be investigating falling objects. We all know that if we drop something it's going to fall down. Now, why does it fall down? You might say it's due to gravity, and you'd be right. The potato and the earth are both exerting an attractive force on each other. The name of the force that the earth is exerting onto the potato is called weight, and it is this downwards force acting on the potato called weight that causes it to accelerate towards the centre of the earth. So we're going to be investigating falling objects and measuring how long it takes them to get to the ground when we change some variables. The object we're going to be dropping is called a whirlicopter. For this you're just going to need a piece of paper, a pencil, some scissors and a ruler. It doesn't have to be a long ruler like this, I just couldn't find a shorter one. First thing I'm going to do is I've taken an A4 piece of paper and cut that in half lengthways. Again, it doesn't make any difference if you don't have any A4 paper. Any paper is going to work. About this sort of shape is what you need. It doesn't have to be as big as this. I'm going to take this and fold it in half lengthways, just gently, just so I can find the middle. With my pencil, I'm going to roughly find the middle of that line. Again, it doesn't have to be exact. Roughly find the middle of that line and draw a line to the end. I'm also going to take the ruler and draw another line about there. Okay, just right the way across. So my piece of paper now has two lines on it, one from here to here and one across. Now this line across, I'm just going to split that into three, just by eye. So I'm going to make a mark here and here. Now for my cuts with my scissors, I'm going to cut this line here and this line here. Make sure you don't cut all the way across, I shall have to start again. So just making two cuts and then taking these two parts and folding across. So you end up with a sort of a fat T shape. The last bit of cutting you need to do is just along your line there. Okay, so now you've got those two flaps. Take one of these are going to be its wings, take one, fold forwards, turn it over and then fold the other one in the same way. So that is now your finished whirlicopter. To drop your whirlicopter you need to take just two wings, hold them in your hands, hold it as high as you can and then just let go. The whirlicopter should go into a slow fall before it hits the ground. In your investigation you're going to time how long it takes for the whirlicopter to hit the ground from when you release it. So just use a normal stopwatch on your phone or on your watch and you're going to start when you release and stop when it hits the ground. So start, stop. To make sure that we've got good results, we're actually going to do it 3 times and take an average. The independent variable in this investigation is going to be the wing length. So I've put my ruler next to the wings and I'm going to mark out from 0, where the wing starts, every centimetre. So my wing length is actually 14 centimetres. Yours may be shorter, it doesn't matter. I've already taken my first result for 14 centimetres. What I'm going to do now is just use my scissors to cut 1 centimetre off the wings. We're doing it from both wings, so 1 centimetre from both wings. My wings are now 13 centimetres long. I'm going to drop this again, taking as many readings as I did before, taking the average, and then come back and cut another centimetre off the wings. I'm going to do this until I've got to the bottom or until it's too difficult to measure the time. So this is what your table is going to look like. You're going to have your independent variable here, which is the wing length measured in centimetres. You're going to take your time 3 times. So time 1, time 2 and time 3, all in seconds. Now your stopwatch may measure to 1/100 of a second. you're probably not going to have reactions good enough to be able to record to 100th of a second. And so just take to 1/10 of a second on your stopwatch. The average time, also in seconds, you're going to work out the average by adding these three numbers together and dividing by 3. That's going to give you your mean average. Just remember when using your calculator that when you add these three numbers together, you have to press equals to get the sum of those numbers before you divide by 3 to get the average. When plotting your graph, you're going to be plotting wing length on the x-axis and average time, that's the full time, on the y-axis. I'm going to leave it to you this time to decide what your graph should look like. For your write-up, you're obviously going to need to do table and graph and conclusion. But what I really want you to focus on in this investigation is your variable. There are independent variables. This is what you're changing. You've got your dependent variable, that's what you're measuring, and you've got your control variables. That's what you kept the same each time. In your write-up, I obviously want you to say what your independent and dependent variables were, but also I want you to make real effort to think about as many of the control variables that were important in this investigation and why they were important. Have a think at what would have gone wrong if you hadn't controlled your variables. For your extension work, I'd like you to have a think about how you could extend this investigation, how you could take it further. What other measurements could you make? How could you change it to make it a better experiment? Have a think about accuracy. How could you make this experiment more accurate? Use your imagination. Think about equipment that might be out there that you don't have in your home. For your challenge work, try and find out something about terminal velocity. Which sort of people are interested in terminal velocity and how people are pushing the boundaries to make things go faster and faster. Finally, before you even start your experiment, I want you to think about your risk assessment. How are you going to make sure this is safe? The most likely thing that's going to happen is if you're stood on something to try and make yourself taller and you fall off it. So it's best not to stand on anything at all when doing this experiment, but just do it stretching up as tall as you can. You're much likely to be safe there. Okay, it's time to go and do some work now. Bye-bye.